Yeah, so we'll start with the first part, which will deal with the water policies and governance. And first, I will introduce the various water policies at state as well as national level, and then I will discuss the governance structure in Maharashtra. And more or less, the governance structure in each and every state is more or less similar with slight variation. So we will start with the water policies. So let's discuss the hierarchy of legal instrument in water management. So at the top, there is the Constitution of India, which made a provision of allotting this water management subject to central government, state government, as well as local self government. We will discuss it later on very soon. Then we have national water policy. We also have state water policy. So national water policy recommend each state to formulate its own policy for every state, considering their socio-economical growth, water availability, the agriculture, and other sectors. Then we also have at the fourth level we have several acts. So there are some acts at central government level and some acts at state government level. Next comes the rules, manuals, and handbooks. And at the last end of the pyramid, there are government orders. In Maharashtra, it is known as a government resolution. In short, it is known as a GRs or circulars, which are issued by the government. So, as per our Constitution of India, India is a union of state, and there is a center as well as state government in power. And as per Constitution of India, there are some subjects allocated to state government, and some subjects has a pivotal role of the state government. And as per our Constitution, the jurisdiction of water management is specified as follows. So, as per 7th schedule, list 2, the state subjects are mentioned. So water including irrigation and canal, drainage and embankments, water storage and water power. That means water management within the state, including dams, canals, hydropower, are the responsibility of the state government. But there is a catch in this. As per 7th schedule, list 1, there is a central subject. So when there is a concern of regulation and development of interstate river, for example, if you take the example of Krishna River, it is an interstate river. So if we try to plan, the Krishna River flows through Maharashtra, Karnataka, Andhra Pradesh, and Telangana. So if any one of state wants any big project on this Krishna River, then concurrence of the other state is required. So that's why this become a central subject. So if river is an interstate river, then that subject, that approval needs to obtain from the central government with proper concurrence of the other states. And if central government makes an act in a parliament that some project has to be executed, which will have wide development, and then such projects are also treated as a national project. In that case, central government jurisdiction comes into picture. So basically, as per our constitution, the water management basically is dealt by the state government, and if there are policy matters or interstate matters, then the subject is dealt by the central government. The second, at the second point in this pyramid, there is a national water policy which was published in 2012 by the Ministry of Jal Shakti Mantralaya, Government of India, and draft national water policy is also available on website, which was published for public opinion, and it can be reviewed. And very soon we will have new national water policy. As far as water Maharashtra state is concerned, Maharashtra has state water policy which was amended in 2019. We will discuss the provisions of this policy in detail next slide. And we also, in this Maharashtra state, we also have integrated state water plan, which was approved by the Council of the State Water Council, headed by the Chief Minister, Honorable Chief Minister. And this integrated state water plan was approved by 2018. So in Maharashtra, the Maharashtra State Water Policy and Integrated State Water Plan are the basic documents which govern the water management in the state. Apart from this, there are several acts at central government as well as state government. For example, in Maharashtra, we have Maharashtra Irrigation Act 1976, which is for managing the irrigation facilities. Then, in order to promote the participatory irrigation management, we have management of irrigation system by Farmers Act 2005. In short, it is known as the MMISF Act. From regulation perspective, we have MWRRA Act, that is Maharashtra Water Resource Regulatory Act 2005. We also have 5 irrigation development corporations, and 5 acts were made in order to formulate these corporations. Then we also have Land Acquisition Act. The older was 1893 and recent act is 2013. We also have Rehabilitation Act for Maharashtra state. The Maharashtra state enacted first irrigation Rehabilitation Act in 1976. It was amended in 1986, and finally it was amended in 1997. And recently in 2013, we have Central Government Act. So all these rules and regulations governs the water management. Then also under each act, there are specified rules. So act is a basic framework which prescribes how the governance is to be exercised, and rules are the further detailing of that section. And in government resolution, it is a very dynamic thing. So whatever change, suppose any financial powers is to be given, so that financial power cannot be mentioned in the acts because it is a dynamic number figure. It varies because of the inflation and there are several factors. So such numbers are never mentioned in the acts as well as in rules, and for that GR or government resolutions are used. So we will discuss in very brief this Maharashtra State Water Policy. The first Maharashtra State Water Policy was enacted in 2003 and it is revised in 2019. Its objectives include the ensuring the clean water and sanitation within the state, to build the resilience for water scarcity and drought, in order to have judicious and strategic sectoral allocation. So this is a very difficult area to manage. Sectoral allocation means allocating water for each sector. There are several sectors, for example, drinking water sector, agriculture sector, industry sector, environment sector, like that. So there is always competition between these sectors, and the water management is very challenging because available water is limited and each sector demand more and more water. For example, in Pune city, the all the dams which are constructed on the upstream side of Pune city were planned for agriculture purpose. But as city development, city started developed, the agriculture water has been transferred for the drinking purpose. So this diversion of water from agriculture purpose to the drinking purpose is a very challenging situation, and it needs to be handled very rightfully without violating anybody's right. Then equitable distribution of water. While supplying water for agriculture purpose, there is a command area. We will discuss these terms in upcoming slides. So within a command area, the area of land can be 1 lakh hectare. So each parcel of land should get some specified quantum of water, and this is known as the equitable distribution of water. So this policy prescribes the equitable distribution of water. Then it also prescribes the protection of ecosystem, enhance water quality, increase in productivity and efficiency of water use, and ultimately it should result into integrated water resource management. As I mentioned that Maharashtra state also formulated integrated state water plan, and this plan was suggested by national water policy as well as state water policy. So this plan adopted basin wise development approach. So we will discuss in upcoming slide how many basins are there in Maharashtra and how water is being managed in this basin. So the important facet of this ISWP is it is a multidisciplinary in approach. So there are several disciplines or streams which are considered in this plan. For example, geography, demography, topography, soil, geology, hydrogeology, agriculture, hydrology, hydrometeorology, irrigation, water conservation, drinking. So and each and every factor, groundwater, natural disaster, legal aspect, these are considered while preparing this plan. So this is a very big voluminous document which is also available on WRD website. Then it also involves involvement of all the stakeholders. So the stakeholders in ISWP are government organizations, farmers, representative from industries, and these the government had taken an approach in order to get the comments from the citizens as well. And this document highlights the demand and supply of present and future. So what are the present water use? what quantum of water is available as of now, and how it is being distributed in various stakeholders. It is anticipate, it is project, it is prepared, from a plan is formulated, and what are the future prospects for development of each sector. So in this plan, attempt has been made in order to establish, estimate the water quantity, quantum of water required for the agriculture sector in 2020. So how to mitigate that water, how to get that water has been identified, and this plan has been made in order to make available that water from either by saving or make efficient water use, or by interbasin transfer. Then this plan also identified the ecological need of water. Then in Maharashtra, there are 6 river basins. So initially, river basin plans for each river basin is prepared and it was approved, and ultimately integrated state water plan is prepared and it is also approved. In from legal perspective, there are several acts, and this is just brief summary of the acts. At national level, as I mentioned, as per 7th schedule list 1, the water is a central subject if that river falls as a interstate river, and in that case, provisions of Interstate Water Dispute Act comes into play, and there are various tribunal awards which are as good as acts, and based on these awards, the water management in individual state has been carried out. Then there is a Pollution Control Act. For irrigation management, there are basically 2 acts. Bombay Irrigation Act 1879 is repealed by the Maharashtra Irrigation Act 1976. Then we have, as I mentioned, there are 5 irrigation development corporation which are carrying out the work of construction management. In Maharashtra, we have MMISF Act in order to promote participatory irrigation management. From regulation perspective, there is a MWRRA Act, and this act prescribed Maharashtra Water Resources Regulatory Authority, which is a apex quasi-judicial body. So its objective is to resolve dispute between water supplier and water user. It also has a power to clear irrigation projects, and these projects shall be aligned with the provisions made in the integrated state water plan. Then this authority issues the water entitlement for drinking and industrial use. This is a very big subject. So how much water should be allocated for the drinking purpose and for various industrial use? Then this this authority prescribed the water tariff. So this is one of the important tasks of this authority, to prescribe water pricing for irrigation as well as non-irrigation use. And this authority prescribes generally telescopic rate of water structure for non-irrigation use. Then in Maharashtra, in 2009, Maharashtra Groundwater Development and Management Act is enacted. And over and above, there is a Disaster Management Act, which has a provision regarding to floods, droughts, and any other disaster which are caused by the water. The participatory irrigation management is a upcoming big area, and in order to enhance or promote the PIM, the Maharashtra decided to formulate Water User Association. So WUA, that means Water User Association, are mandatory for all ongoing projects, and size of WA is it depends on the area of land holding. So for 500 hectare area, there is one WA, and it is a body of persons including male and female landowners, and this body makes the water management within their jurisdiction, and they follow tail to head irrigation. So if water is released from canal, water will reach first to the tail part and then it will come to the head. So as per water pricing policies, there are concessional water rates for the WAs in order to promote this formation of this WA. And also important feature of this WA is we supply water on volumetric basis. And also whatever water charges WA gives to the government, 50% of that is refunded to the WA in order to make their O&M, operation and maintenance, has to be made by these water charges. Then women participation is mandatory as per Act, and this WA has a crop freedom. So this is a very important concept because Maharashtra Irrigation Act has a stringent policies regarding taking up crop. So as per this act provision, the superintending engineer has to make a declaration to all the farmers in order to grow specific type of crop. And if any farmer do not follow the orders of superintending engineer, then superintending engineer or executive engineer is authorized by this provision of this act to not to approve the water for that farm. But as per this MMISF Act, the farmer is given crop freedom. So farmer can grow any type of crop provided that specified quantum of water is supplied to the farmer, and he has to manage the entire cropping cycle within that quantum of water. And its structure is like there are 4 tier structure. In the next slide we will discuss. At the apex level there is a project level association, it is known as a PLA. At the secondary level, there is a canal level association. If a project has a 2 canal, then there will be 2 associations, one for left bank canal, another for right bank canal. Then each canal have several distributaries. Then we will have distributory level association, and ultimately we will have water user association. So it is a hierarchical structure, and the members of WA are elected members from the persons who are holding the land. Then another important policy executed by the Maharashtra government is the policy of piped irrigation network. So government adopted a policy of piped irrigation network in 2017, and as per this policy, instead of conventional canals, piped irrigation network is proposed, and this PIN is successfully implemented in Tembu project. So and it is being implemented in Gunjoni project. In Tembu project, is a hybrid system. So part of this project is a conventional canal and part of it is a covered in a PDN. And whereas in Gunjoni project, water is being supplied through through pipe network in within an entire command area. So I will show very small 5 minutes video on the Gunjoni project in the upcoming slides. So we are clear with the legal mechanism. Now we will discuss the water governance. So water governance, it is a 3-tier structure. At the top, there is a Ministry of Jal Shakti, Government of India, and role of this ministry is to formulate the policy matters and to clear the interstate rivers or interstate projects and to resolve the disputes between the various states. At the second level, we have state government, and as per our constitution, water resource management is entrusted with the state government. So generally, each state government has 2 departments. One is managing surface water, and another is managing the groundwater. And as per another amendment in the constitution, local self-government has been formed. And this local self-government, like Jilla Parishad, Panchayat Samiti, they manage irrigation projects through their minor irrigation department. So basically, we can say we have a 3-tier structure of governance. At the top level, there is a Ministry of Jal Shakti, which formulate the policies, resolve the issues between the various states governments. At the middle level, there is a state government, and at the lowest level, there is a local self-government. So, for Maharashtra, there are several agencies which are responsible for managing water. For example, Maharashtra Water Resource Department, the department in which I am working. This department manages irrigation projects having irrigable area more than 600 hectares. Then we also have water conservation department. This department implemented the scheme of Jal Yukta Shivar. So scope of this department is to manage irrigation projects having IC irrigable command area of 100 to 600 hectares. And as I discussed, we also have Jilla Parishad Irrigation Department, which manages irrigation projects having command area less than 100 hectares. Then we also have agriculture department, which gives subsidy for agriculture pond, then other water conservation works. There are several private lift irrigation schemes which are intended for irrigation purpose. Then forest department executes small pond structures in the forest jurisdiction. In Maharashtra, there is a Maharashtra Jivan Pradhikaran, which supply water for drinking purpose. We also have Maharashtra Industrial Development Corporation. This MIDC also has some dams. We also have SIDCO, then other Mumbai Corporation. So these agencies have some agencies have their own water sources like dam, and some agencies have agreement with water resource department, and they through that agreement they take the water from these dams which are constructed by the water resource department, and they pay for that the fee of water. Then in Maharashtra, there are private companies like Tata Hydro Power. They also possess about 5 dams in Maharashtra, and they also use water for electricity generation. For groundwater management, there are two bodies. At the state level there is a groundwater board, and at central level there is also groundwater board. So these bodies manage the groundwater, and there are also private or open wells or bore wells. In very brief, I will discuss the organization structure of the government of Maharashtra, Water Resources Department, government of Maharashtra. So in order to take all the policy decisions, there is a mantralaya, and it is headed by the minister and state minister, and these are supported by the principal secretary and secretary and the subordinate staffs. And department also has a chief engineer hydro and quality control, also has a chief engineer electrical, which manages hydro projects as well as lift irrigation scheme. And we also have chief engineer mechanical Nasik. Then at second level we have design research and training wing, which is headed by the director general and supported by the chief engineers, superintending engineers. At the third level we have regional level administration, and there are 5 irrigation development corporations headed by the executive director. So one corporation is at Pune, another is Aurangabad, another is Nagpur, Jalgaon and Thane. And these IDCs, irrigation development corporations, are supported by the chief engineer and superintending engineer. And at the lowest level for execution of works and water management, there are superintending engineers, executive engineers, deputy engineers, and sectional engineers. So this encompasses the governance structures in the Maharashtra. So in the second part, we will discuss the water infrastructure. So I think we can have a break, and we can discuss. I can address the issues, if any, regarding to water governance. So please let me know if you have any question.
Yeah,
otherwise,
Bakshish has raised his hand. Bakshish.
Yes, sir. Sir, I had a question.
Yeah.
So sir, I might be digressing a little from the topic, but I was curious to know that when you spoke of like at the central and the state level, we have CGWB, the Central Groundwater Board. But when we're talking about water, pollution is also something which is very, like in Maharashtra does have. I've lived in Maharashtra while I was studying at Tata Institute. So I have also understood in my classes, understood about the water contamination also found. So just out of curiosity, sir, because you are in the department. So how do CPCB, Central Pollution Control Board, and Central Groundwater Board speak to each other? And if they do, like how does that function?
Yeah, it's good question. Actually, you had raised a very valid point. I had forgotten this perspective of legal aspect, although I had mentioned the name of act. So we have in Maharashtra, we have Maharashtra Pollution Control Board, which is similar to the Central Pollution Control Board. So as water management, we have 2 agencies at central level as well as state level. Similarly, for managing pollution, we have 2 agencies. So at central level, their job is to formulate the policies for all the state, and for at local level, at state level, the MPCB's task is to monitor these policies. So MPCB is very big organization, which the major task of this MPCB is to provide environment clearance, then to monitor the air quality, water quality, solid waste management. So the task entrusted to the MPCB is very huge vis-a-vis the organizational structure of this MPCB. So as an IIT student, I urge you to just go through the MPCB website and understand their structure. So as far as a role of MPCB in water quality management is concerned, because of very few number of staff, it is not possible to collect the water samples from surface water bodies as well as groundwater bodies, although they have some specified sample locations. But considering the dynamic nature of the water resource management, water resources, because if you take sample today and if you take sample 1 week after, the water quality may change. And although and the water quality also change from at various space. So MPCB do not have enough infrastructure to take the sample, number one, and number two, the punishment mechanism is I think that needs to be made proper. And thank you for bringing out this point. So to answer specifically your question, we have two agencies at central level, CGWB, Central Groundwater Board, and at state level we have MPCB. So Central Groundwater Board's task is to monitor the groundwater. So they have policies regarding extraction of groundwater, and MPCB's task is to regulate the water quality. I hope I answered your question.
Yeah, so actually, I was trying to understand how the Maharashtra Pollution Control Board and the state executionary organizations, like the state department, speak to each other, and how they come in when it's about policy making, and also on the ground. On the ground, how they interact with each other, the two certain.
Yeah, so there is a link between the water management. For example, I will cite the example of my department. So when we supply water for any industry or any Mahanagarpalika or corporation, then we ask the corporation or the non-industrial water user to bring a certificate that he had not created or caused any water pollution. So whatever water he had used, either it is consumed by that organization, or if it is released in the form of sewage or something, then it is 100% treated. So MPCP tracks tracks the process, and they issue a certificate. And based on this certificate, when the water pricing is decided. Suppose for 1 unit there is for 1 meter cube, the water charges is 1 rupees. And if pollution control board says that this agency has caused the pollution, then we will employ the penal charges for the pollution, and we will recover accordingly. So there is a communication between the department, MPCB, and the end user. And using this punishment mechanism, the department tracks the pollution. Is it okay?
Yes, sir.
Yeah. Any other question?
So there is one question in chat also.
Okay.
I will read it.
Yeah.
Maharashtra Water Resources Regulation Authority have State Groundwater Authority, which has 5 members. There is no groundwater member in the current committee. Why this not appointed? And also there is no meeting happened till now. This is by Swapnil.
Yeah, Swapnil, you are correct. But actually, the chairman and member of this authority is appointed by the honorable government. And since last 1.5 years, because of the COVID situation, the recruitment process or enrollment process of the members and chairman is not taken place. But as of now, I think most of the members from the MWRRA has been appointed, and the process of the appointing the members from for the state water authority, state groundwater authority is in process. So in government, there are several issues like publishing the advertisement for the appointment, then their recruitment and the enrollment process. So because of the delay due to the COVID situation, the appointment could not succeed. Is there any supplementary question to this?
No. It's
okay. Yeah. Okay. Thank you. So, is there any other question, or shall I continue?
Yeah, I think we can continue. Maybe we can then take towards the end of the session.
Okay. Yeah. Good. So I think I have nearly less than 1 hour. So I will a little fast. So in this part, we will discuss the water infrastructure. So in Maharashtra, as I discussed, there are 6 river basins. So the biggest or most important river basin is the Krishna River Basin, which has about 13% water. Then we have Godavari Basin, which has about 27% of water. So whatever water is available, from that water, 13% is available in Krishna, 27% is available in Godavari, 1%, 4% water is available in Tapi Basin, and only 0.1% is available in Narmada Basin. So from these four basins, about 45% water of Maharashtra is available, and on this water 92% cultivable land is dependent. So you can see the skew between the water availability and dependent cultivable land. And there is a important basin in the Konkan, which is known as a west flowing rivers, which has about 55% water and only 8% cultivable land. And there is a very small part of Mahanadi basin in the eastern side of the state, but from hydrological calculation, that basin is not been accounted. So in a nutshell, from hydraulic perspective, Maharashtra has 5 river basin, and this 5 river basin has been subdivided into 25 sub basins, and 25 sub basins has been divided into 1,505 watersheds. The yearly rainfall of the Maharashtra is ranges from 400 to 6,000 millimeter, and average rainfall on interstate is 1,067 millimeter. But there is a spatial and temporal variation, and if you understand these statistics, you will realize why water management is very difficult. In our country, the water is made available through rainfall, primarily through rainfall, and generally rainfall occurs during the monsoon season. And the monsoon season is of 4 months in a year. If in these 4 months, if we count the actual number of days of rains, then average for the last 10 years, it has been observed that there are only 14 rain days in the 4 months of monsoon season. And if we count the actual rain hours, so in these 14 rains, how many hours there was rain, the number of hours comes to be 96. That means only 4 days in a year. So the task of water manager is very difficult. So they has to collect the water which is made available through rain in their dams, and time for this collection is only 4 days, and they has to manage this water for entire years without causing any flood or drought. So that's why this task is very challenging. And in Maharashtra, 40% area is drought prone, 7% area geographic 7% of the geographical area is a flood prone area, and there are 148 tahsil of the states are drought prone states, drought prone tahsils, and at our country level there are 971 tahsils which are drought prone in nature. So in Maharashtra, development of irrigation started with the tank and well irrigation, and in Satara there is a Bara Motechi Vihir. Vihir means well, and from this well the irrigation actually started. In Vidarbha region there are Malguzari tanks, and through these tanks irrigation started. During British era, they constructed several big dams. So during the period of 1885 to 1930, they constructed several large irrigation schemes, which are very huge irrigation projects. They constructed Khadakosla irrigation project, Bhatgar project, Godavari irrigation system, Bhandadara irrigation project, Pravara system, and each of these projects is known as a system. Bhatgar Nira system, Khadakosla system, Pravara system, like that. And they stored the water. In the next slide, I will show the topography of state, and you will realize why they constructed dam and network of canals in order to provide water to the drought-prone area. Then they constructed a huge network of canal and water aqueducts. So this is one of the photo of water aqueduct in which water is being translated from the dam to the command area. They also constructed some tunnel. After post-independence, there was a boom of irrigation development in the state, and there are several large-scale irrigation projects are undertaken in the states. In this slide, I will just explain briefly topography of this state. So on the west side, there is a Sahyadri mountain. The height of Sahyadri mountain is more than 650 meter from the mean sea level, and rainfall is about 6,000 millimeters. So there is a huge rainfall in the ranges of Sahyadri mountain, which is a part of Western Ghat. And so in British era as well as post-independence era, the Water Resource Department constructed dams at the valley. So at the dam location, rainfall varies from 800 millimeter to 1200 millimeter. And the area which is actually cultivable lies on the eastern side of the state, whose average elevation is about 500 meter to 600 millimeter from the sea level. So we are fortunate to have ample water available through rain on the western side and at quietly higher elevation. And on the eastern side, we have a cultivable land. So what Water Resource Department decided to construct series of dams. And on the eastern side, rainfall is hardly 300 to 600 millimeter. So most of the water, as in the last slide also we discussed, 55% of the water is available in the western side. And other 92% area is dependent on the only 45%. So most of the dams situated in the Sahyadri ranges, and there are network of canals as well as lift irrigation schemes and tunnels in order to divert this water from abundance area to the drought prone area. And there are several lift irrigation schemes. So water is being lifted from one elevation to another elevation. And this is a photo of Purandar lift irrigation scheme from Pune. So every year this scheme lift 4 TMC water. TMC means 1000 million cubic feet. And it irrigate about 25,000 hectare area. Water is lifted for about 356 meter head. So there are 6 stages of lifting. Then we also have Tembu lift irrigation scheme, which is one of the biggest scheme in the Maharashtra. And about 22 TMC water is used every year. It irrigates 80,000 hectare area, and water is lifted in 5 stages. We also have Krishna Koina lift irrigation scheme, and it irrigates about more than 1 lakh hectare area, and it is also multi-stage lifting project. So from this photo, you will realize that, and from the last slide, as we discussed the topography and rainfall pattern, it is essential to have lift irrigation project in the state. So how water infrastructure is constructed and managed? So water infrastructure is constructed based on the basin planning approach. So in Maharashtra, we have irrigation development corporations, which are converted into river basin agencies. So for western Maharashtra, we have Maharashtra Krishna Valley Development Corporation. For Vidarbha Valley, we have Vidarbha Irrigation Development Corporation, then Tapi Irrigation Development Corporation, Konkan Irrigation Development Corporation, and we also have Godavari Marathwada Irrigation Development Corporation. So why basically we plan for a water resource project? So first purpose is to have a assured source for a drinking or domestic use. Then second use is to have irrigation facilities. Third, to supply for water for industries. Fourth, to generate electricity through hydropower schemes. And last, for flood protection. So these are the purpose of convincing a water resource project. And in Maharashtra, these water resource projected, and they are classified based on the irrigable area. So as I discussed in earlier slide, Maharashtra Water Resource Department has a jurisdiction based on the cultivable area. So all the projects which are having irrigable area more than 600 hectares are managed by the WRD. So these projects are classified into 3 types: major projects having area more than 10,000 hectares, and in Maharashtra there are 28 completed and 66 ongoing projects. In medium project category, the command area lies between 2,000 hectares to 10,000 hectares, and there are 188 completed and 82 ongoing projects, and there are about 2,987 completed and 211 ongoing projects, and these projects are known as the minor projects having irrigable area less than 2,000 hectares. So in a nutshell, in Maharashtra there are more than 3,000 completed projects and 359 ongoing projects, and this pie chart shows the number of irrigation projects in Maharashtra. So Maharashtra has highest number of dams in our country. About 36% of dam are in Maharashtra. But still, if you see the water management situation in Maharashtra, it is not that good. And in the next slide, we will discuss the reason for this. So geographical area of state is 307 lakh hectares. but cultivable area is 225 lakh hectare. Because of the forest land and urbanization, entire geographical area cannot be irrigated. So cultivable area is only 73% of the gross geographical area. So it has been assessed that from surface water, we can irrigate only 85 lakh hectare area. So out of 225 lakh hectare area, 85 lakh hectare area can be irrigated by the surface water. That means dams, canals, rivers, etc. About 41 lakh hectare area can be irrigated by the groundwater. And there is the larger chunk of the cultivable area is irrigated by the rainfed irrigation. 44% of the cultivable area is currently irrigated through rainfed agriculture. So as far as Maharashtra Water Resource Department is concerned, so target of MWRD is to have a irrigation facility over 85 lakh hectare area. So if we compare this target, as of now, the department has created irrigation potential on area of 51 lakh hectare. That means irrigation facilities are created on this area, but actually potential utilized. So we had created irrigation infrastructure on 51 lakh hectare area. That means there is a dam, there is a canal, and we can supply water to the land. But actual irrigated area is 42 lakh hectare, and there is a gap between potential created and potential utilized, and this is also a research topic, why there is a gap, although we had incurred expenditure and created the infrastructure. So percentage of irrigation potential created with respect to cultivable area is only 23%. So although we saw there are 36% dams in Maharashtra, the irrigable command is only 23% through surface water, and percentage of irrigation potential utilized with respect to irrigation potential created is 18%. So from this slide, we can identify three important challenges for Maharashtra. So first important challenge is to have to convert this rainfed area into the assured water supply area, either from groundwater use or surface water use or optimum water use or conjunctive water use. Second challenge, and how to improve the water use efficiency. We can also have new irrigation projects. We can also have an inter-basin transfer, that means river linking. So this is one of the solutions proposed by the integrated state water plan. So to divert surplus water from the Konkan region to the adjoining area is also suggested. Then second challenge is to have maximum quantum of irrigation potential. So in order to achieve this, we need to complete all the ongoing projects and all the future projects which are in MTech in order to create the irrigation potential of 85 lakh hectares. And third challenge is to mitigate the gap between irrigation potential created and irrigation potential actually utilized. And in order to do this, there is a need of maintaining the irrigation infrastructure, extension and modernization of the irrigation infrastructure. So this is the end of second part. We had just discussed the irrigation infrastructure. So if you have any doubt, we will take a break of 1 minute and we can discuss. So please let me know if you have any question.
Digvijay has raised his hand. Digvijay, please go.
Yeah, sir. Okay. Yeah, hello, sir. Sir, recently in last 3 years, we have seen that 2 times the flood has came to Kolhapur and Sangli districts.
Yeah.
So are there any flood mitigation measures or any plans that are planned by water department?
Yeah. So you might heard about the Vadneri committee. So government established a panel of experts in order to identify the reasons of flood and to suggest the remedial measures in order to avoid the upcoming floods. So that committee had submitted their report. That I was also invited for that committee, and that report is available on the WRD website. This is a holistic report, and we need to understand the reason of flood, and then we will have a mitigation strategy. So number one cause of flood is a extremely high intensity rainfall within a short duration. So I had mentioned the average rainfall of the state is 1067 millimeters. So in this year as well as in the last year, this average has not shifted too much. But what happened? whatever rainfall happened, it occurred in a very small scale, and because of this, the entire whatever quantum of water fall on the ground is reached to the river, and that caused the flood. So this is the first finding of the that committee. The second finding of the cause of flood is the encroachment in the river. And as we all know, the urbanization happened, and because of urbanization, there are several structures constructed alongside of the river, and there are illegal encroachment within a river boundary. So that is the second cause. And there are other causes also mentioned in the committee report, but these are two important causes. And third, the remedial measure proposed by the committee is to have uh, the first, the foremost important is to have a early warning system. So in this presentation, I had made one slide on flood forecasting and early warning system, because nowadays floods are occurring like just like an earthquake, so without any warning and within a very small scale. So we should have a early warning system. So there are models available for that. And on the second phase, we should have the clean river stretch. Then in Sangli area particularly, what happened, there is a meandering in the river. And what happened, because of the Sahyadri ranges, most of the silt comes with the water, and this silt gets deposited in the river body. So these silt, these are the engineering solutions. But I don't know whether these are the best solution from environmental, ecological perspective and also financial perspective. But committee had suggested to strengthen the embankments of the river, then desilting, then strengthening the meanders. And in Kolhapur city specifically, what happened in in the Krishna, the Panchaganga river is there, and because of the confluence of several rivers at one point, it becomes very difficult to accommodate the water at the same time. And because of these issues, the flood happened, and intensity of the flood also increased. And this year also we had experienced the same situation. And there is also one reason cited by the several committees earlier, that effect of Almaty. So Almaty Dam is on the downstream of the Maharashtra state. So I had already discussed, just mentioned the interstate relations. So flood management is also important interstate matter, and Almaty Dam is constructed on the Krishna River. So allegation is like that, because of the backwater profile, water gets the flood happens, and this flood of water damages the Sangli city. So committee has specifically studied this phenomenon, and hydrologic model has been formulated, and committee observed that even though there is no Almaty Dam, then also water profile will remain the same. So in this way, committee tried to find the various causes of the flood and suggested the remedial measure. So I request you to just download the report and go through the executive summary. It is a hardly 10-20 page document, which very nicely summarizes all the things.
Okay, sir. Thank you. Thank you very much.
Also, there is a question in chat by Ambadas. So he asks, what could be the probable reasons of gaps for IPC created and utilized?
Yeah, this is also interesting question. So this gap happens because of several reasons. Important reason being the dependability of the project. So basically, from hydrologic perspective, hydrology is a art and science. So in hydrology, we try to calculate the rainfall intensity, average rainfall quantum. So what happens? This is a statistics. So we cannot accurately predict the outcome of the rainfall event within a year. So what in order to construct a dam, we need to find out its storage capacity. So in order to fix the storage capacity, we have to analyze what is the probable maximum water available at this point. It is known as the yield at that point. So generally, major and medium irrigation major projects are constructed on a river which is having 75% dependable yield. What this yield means, out of 100 years, at least 75 years, this dam will be filled 100%. And for rest 25 years, there may be less inflow as compared to the reservoir capacity. That means, and this we had taken this stand considering the cost economy of the dam. Suppose if we want to have 100% storage capacity, then the size of dam will be very huge. So considering this perspective, we compromise on the storage capacity of dam. And because of this, what happened, there are some, and for minor irrigation projects, in the last slide I had mentioned that there are more than 3,000 minor irrigation projects. So minor irrigation projects are constructed for 50% dependable yield. So out of 4 years, only 2 years these dams gets filled because of low inflow. And because of this, what happened, although we create irrigation potential, and if there is no water in that dam, then it is not possible to supply the water. This is the number one reason for the gap. Number two reason is the low maintenance. So what happens if water does not reach at the tail end, then farmer do not maintain the water channels, and government do not have the sufficient fund to maintain these water channels. So this is also a second reason. Third reason is that while having an irrigation canal, so you just go through the Google Earth and see the irrigation system of the Bhadgar Dam or Bhandartara Dam. So its canal stretches about more than 100 kilometers, and an official command area of this canal is only on one side, because these are the control canals. So this canal can irrigate only one side, and other side, as per project report, it is an uncommand area. So as per project report, we are not supposed to supply water on the other side. But since water is passing through adjoining land, so there is a tendency of farmer to either have a well or either have a siphon, that means lift the water from the canal and they can irrigate the adjoining land. And because of this, there is a less water available at the tail end. And because of this, there is a gap, there occurs a gap between irrigation potential created and utilized. And apart from this, there are several factors and there are several research has been carried out on various irrigation projects why there is this gap and how to mitigate this. And this is also very important area, because government also already incurred the expenditure to create the facility. And if that facility is not being 100% used, then it is a cause for concern. Hope I address your query. Shall we move ahead? Hello?
Yeah, I think we can move ahead. Bakshish is raising his hand, but can you take your question later, Bakshish? Or is it
right.
in this context?
All right, Shash, maybe I'll put it at the end of the class.
Yes.
Yeah.
So this is the third part of my presentation. In this part, I will discuss the practical water management activities. So as we know, generally water management, there are three basic sectors of water users. First is domestic sector, second is industrial sector, and third is the agriculture sector. And if we average out all the numbers of the domestic water use across world, then 8% water is used for the domestic purpose, 22% is used for the industrial purpose, and about 70% water is being used for the agriculture purpose. If we see high income countries, then only 59%, or the 59% highest quantum of water is used for the industrial purpose, and only 30% water is used for the agriculture sector. If we see the scenario of water use in the state, then we will find that 82% water is used for the agriculture sector. And in this 82% water management is a big task. So water is managed by following the RWS method or Warabandi method. RWS means rotational water supply. So in this RWS, water is supplied to crop in rotations through canal or pipe network. So what in the crop planning or irrigation project planning, what we do generally, we divide entire cropping season into number of fortnights. So whatever quantum of water required in that fortnight is calculated. Then we will deduct the water available from the external source like rainfall or groundwater, and whatever quantum of water is remaining, which is required to be supplied through canal, is estimated. and this quantum of water is supplied through the canal. So it is anticipated that at every 15 days interval, water will be supplied to the crop. And this Varabandi is a Urdu word, Var and Bandi. Var means turn and Bandi means fixation. So turn by turn water supply after a fixed schedule is a Varabandi. And generally in Maharashtra, Varabandi pattern is followed. And there are legal provisions backing this mechanism. So in Maharashtra, canal operation is governed by the state water policy as we discussed earlier. Then we have Maharashtra Irrigation Act 1976 and Bombay Canal Rules 1935. So water is supplied to the individual farmer based on area and crop. And since I had already mentioned that the superintending engineer issues a notification that which crop has to be grown. So based on that crop, water is being supplied through canal. Then as per Maharashtra Cooperative Societies Act 1916, as well as MMISF Act, as we discussed earlier. So these are two legislation which support the water user association formation, and the water is supplied based on the volumetric basis to this WA. Then there is a PWD handbooks, chapter number 25, irrigation and irrigation management. Then we also have MMISF Act for participatory irrigation management, and this act enables the volumetric water supply to the WS, and there are various GRs and circulars. So the process, we will understand the process of rotational water supply. So in this process, there are six stages. For our understanding, I had divided this in 6 stages. First stage is preparation of PIP. PIP means a preliminary irrigation program. This is a program how water will be supplied for various sectors. Then how many rotations, when to start the rotation, when to end the rotation. So this is a preliminary program. Then there is a participatory mechanism known as a Canal Advisory Committee. So we will discuss this in detail. Then at the third stage, there is a rotation planning. So actually carrying out the rotation. Then fourth is a during rotation. So there are several activities which needs to be carried out while rotation is going on. Rotations means supply of water from dam to canal to the individual farmer. And there are some activity which are required to be carried out, like measurement of the crops, the billing of the crops, like that. And ultimately we have CIP, that is completed irrigation program. So we start with the PIP and end with the CIP. So what is a PIP? It is a preliminary irrigation program, and as in Maharashtra, water planning is done as per, this is a date of GR, that is government resolution. And as per provision, preliminary irrigation program is prepared for all the projects. So for each and every project, this PIP has to be prepared. And there are specific guidelines for the normal year and deficit year. So if in any year, our IMD, Indian Meteorological Department, declares that there is a possibility of drought in the next year, then our PIP will be different. And if there is normal year or over or average year, then our policies are different. So PIP is prepared for every season, and it is approved by the superintending engineer of that concerned project. And water allocation is based on the directives of state water policy. So in the state water policy, the priority of water use is mentioned. So first priority is given for the drinking water purpose. Second priority is for agriculture. Third is for industrial, and like that. Then we also have to make provision for water entitlements, non-irrigation agreements, and demand for drinking water supply, etc. So considering all the requirements, we formulate what is storage available in a dam and what is our probable uses in each season. So there are basically 3 seasons. So Kharif season, the water planning for Kharif season is done based on the storage in the dam on 1st of July. So whatever storage available in the dam on 1st of July, the water planning has been made. For Rabi water planning, the storage date is considered as the 15th October. So based on the water storage availability in the dam on 15th October, Rabi water planning is done. And for third season, that is a hot weather season, the water planning is done based on the storage on 1st March. So this is a fixed guideline for the water planning. So in brief, I will discuss how water planning is made for the Kharif season. So, sorry, this is for Rabi season. So on 1st October, whatever storage of quantum of water available in a dam, we take that quantum. Then we deduct the probable evaporation loss. So in Maharashtra or in our country or anywhere in the on the planet, about 20 to 25% of water gets evaporated every year. So we have to take provision for evaporation loss. So we deduct the evaporation loss. So this data is available with the dam engineer, and we have pan evaporometer installed across various dams, and based on that data, we deduct the evaporation. Then we allocate the water for each season. Suppose we have 100 TMC water, 20 TMC is evaporation, and remaining 80 TMC we will allocate for each season. For Kharif season, we may have 20 TMC. For Rabi season, we may have 60 TMC. And again, for hot weather season, we have 20 TMC. So this allocation is done based on the project planning report. Then we allocate water for irrigation, drinking, and other non-irrigation use. So whatever water is available in a Rabi season, for example, 40 TMC is available in the Rabi season. So out of that 40 TMC, how much water is to be allocated for irrigation, how much water for drinking, and how much water for non-irrigation? This calculation is done. Then once we finalize the irrigation quota, so for example, in Rabi season, out of 40 TMC of water, if we give 30 TMC water for irrigation, then we will plan for number of rotations. So 30 TMC water will be supplied in about 6 rotation, maybe 5 TMC in each rotation. Then we will propose the start date of rotation and end date of rotation, and we will prepare the irrigation schedule. And as I mentioned that we follow tail to head. So water will reach at the tail. Suppose canal is 100 kilometer long, then once we release the water, then it will reach to the tail portion. So we will carry out the irrigation activity at the tail part, and then we'll come to the head. Then allocate the water for each distributory. See, so in next one of the slide, I will discuss what is a distributory. So we will make allocation for each distributory. So it is a sub canal. Then once this planning is done, this planning is approved by the superintending engineer. And then finally we prepare a Shechpali Patrak. Shechpali Patrak means how water will be, how it is a list of farmers, and date and time is mentioned before their name. So this document tells that who will be the first farmer who will get the water, who will be the second farmer who will get the water after first farmer. So this is just a timetable of water distribution. Then next activity is to propose this planning to Canal Advisory Committee and discuss with the stakeholder and get approval and start the irrigation program. And once this activity is done, we will issue a public notice. So this is a sample public notice, and this notice is published in the leading newspaper, so that we will inform all the stakeholders, farmers, and all the other water users that we will release the water on this date, and about this much quantum of water will be used. So I had mentioned about the Canal Advisory Committee. So this is a structure of Canal Advisory Committee. So I mentioned about the classification of projects. So for major projects, chairman is Honorable Minister of Water Resources or Palak Mantri, the Guardian Minister, and member secretary of this committee is a concerned superintending engineer. Then for medium project, chairman is a concerned executive engineer, and member secretary is project deputy engineer. For minor irrigation project, chairman is a deputy engineer, and member secretary is sectional officer. And the members of this committee, there are official members and there are other members. Official members includes officers from Water Resource Department, Revenue Department, Agriculture Department, Water Supply Department, MIDC departments. And there are public representatives such as minister from state government, central government, MP, MLAs, chairman of sugar factories, district agriculture market produce committee, and representatives from Water User Association. So whatever planning we formulate, we have to present our planning in front of this committee, and this committee can suggest the modification plan. And once approval of this committee is taken, so this is one of the photo, in which all the MLAs and minister gather, and we have to present our planning. And once planning is approved by this committee, the actual rotation starts. So in order to have control on this rotation, we have technical staff. So superintending engineer is the in charge of circle who has to exercise the overall control of the irrigation activity. And under his jurisdiction, there are 4 to 5 divisions. And these divisions are headed by the executive engineers. And for each and every canal, there is a one executive engineer, or less than, for 2 or 3 canals, there is one executive engineer. And below executive engineer, we have deputy engineers. And generally for one tahsil, there is one deputy engineer. And then we have a sectional officer. And this is the last technical unit where water management, accounting and water management is carried out. And in order to support this technical personnel, we have support staff. For record keeping, we have Daftar Karkun and measurer who measures the water use, who maintains the gauge register. So what is the gauge available in the dam, various canal, at various location of the canal. He also measures the area irrigated. He also prepares the bills and collect the revenue. Then we have canal inspector who visit the canal across the season, and he can file FIR if there is unauthorized use. He can take possession of pumps pipe if he found that there is theft of water, and he tries to regulate the water at the local level. Then we have for communication, we have Sandeshak who communicate with the from lowest level staff to the superintending engineer. And at the end, at the last, we have gate operation. There is a canal chowkidar who operates the gates of the canal. So these personnel manage the rotation activity, and after rotation, these people prepare a completion irrigation projects, which is known as a CIP. And they compile the information such as area irrigated in that rotation, quantum of water used in that rotation, what action they took on unauthorized irrigation, and they prepare water audit report and benchmarking report. And these reports are available on WRD website. You just go through it, you will have an idea what this report says. Then the important task after rotation is to prepare water assessment report and get it approved by the executive engineer. So water assessment report is a report which says that this is a farmer, this farmer irrigated this much quantum of land, this much hectares of land, and he had grown the sugarcane or whatever crop. So as per MWRRA water pricing, he has to pay this much quantum of this much amount of fees. So preparation of assessment report and collection of revenue is an important task after rotation. And apart from this, these people have carried out the regular maintenance and repair of the canal works. And I think only 10 minutes are remaining, so I will just go through slightly the piped irrigation network. So there is a need. Why there is a need for piped irrigation network? So as we discussed, about 80% water is being used in the agriculture sector, and design efficiency of conventional canal is 45 to 50%. But actual efficiency, because of theft and water loss because of the improper non-maintenance of the canals, actual efficiency comes out to be 15 to 20%. So it is necessary to increase this efficiency in order to satisfy the need of other sectors, including agriculture sector. And if we increase irrigation efficiency from 20% to say 60%, then we can irrigate 200% more area. And this will also avoid waterlogging, control water supply, equitable distribution, and this will also cause less land acquisition, avoid less head loss, and there will be minimum structure along the alignment. So in this slide, I will just brief you the how conventional canal system looks like. So there is a river, and there is a diversion structure known as a dam. Then there is a main canal uptaking from the diversion structure, and generally there are 2 canals. One is uptaking from right side, another is uptaking from left side. It is known as a left bank canal, and another is a right bank canal. So the canal uptaking from the main canal is known as a branch canal, and there is a specification that its discharge should be more than 3 cubic. Then there is a distributary, then there is a minor, and then there is a field channel. So this is a skeleton network of the conventional canal system. In PDN, we have several combinations. So hybrid PDN is also possible. So there is a reservoir, there is a main canal, branch canal, distributor canal, minor canal, field canal, and ultimately field. So efficiency of the project is calculated as calculated by multiplying the efficiency of the individual component. For example, efficiency of the conventional canal distribution network is calculated as a field application efficiency, means how water is supplied to the field. Then field channel efficiency and canal efficiency. Generally, canal efficiency is multiplication of these three efficiencies, and design efficiency is about 34%. And if this figure shows that if water is supplied through main canal, branch canal, distributory, minor, field channel, and it is the farmer adopt flow irrigation system, then total irrigation efficiency is 34%. But he shifts from flow irrigation to sprinkler irrigation, efficiency increases to 42%. And if he shifts from sprinkler irrigation to drip irrigation, efficiency increases to 50%. So because of the increase in the field application efficiency, our efficiency of entire project increases from 34 to 50%. Suppose if we convert the field minor into pipe network and field channel into pipe network, then how our efficiency increases? So flow application 39%, sprinkler 49, and drip 59. If we replace entire distributory and below network into pipe distribution, then efficiency increases to 45, 56, and 68. And at the second last level, if we replace entire network, canal network below main canal into PDN, pipe distribution network, then our efficiency will be 51%, 64%, and 77%. And at the highest level, if we replace entire distribution system into pipeline, then our efficiency will be 59%. Sprinkler, for sprinkler it is 74%, and for drip it is 89%. So in a nutshell, so by adopting pipe distribution network, we can have about 90% irrigation efficiency. From conventional canal, the efficiency is only 34%. So there will be higher water use. So I will just show this 5 minutes video.
Project consists of earthen dam with side spillway. Maximum height of dam is 53 meters. Storage of 104 million cubic meters, which is 3.67 TMC. Annual utilization is 118 million cubic meters, which is 4.19 TMC. The spillway has 2 radial gates. The project also offers some features which collectively make it a truly unique project. Water will be available 24/7 throughout the year. Piped irrigation network up to the farm. Water can be seen only either in the dam or at the root of the crop. Minimum 20 meters pressure head at each farm of 3 hectares. Command area is 21,392 hectares in Velhe, Bhor, and Purandar. Out of this, 12,872 hectares is a drought-prone area in Bhor and Purandar Taluka. Narayanpur lift irrigation system of 2 stages with head up to 281 meters. Command area of Narayanpur lift irrigation system is 5,400 hectares. The system is fully automated and with HSCADA system. 173 water user associations planned. This project is divided into 2 parts. The first part is the first one of its kind in India. It's a stretch of 86 kilometers main pipeline covering 16,000 hectares, which is approximately 75% of the command area, and works on the gravitational head of the dam. Since there is no energy used in this system, a huge saving in the power is achieved. Despite the absence of power, the system is capable of providing minimum pressure required for drip irrigation. The second part is a lift irrigation scheme named Narayanpur, which starts from 58 kilometers of main pipeline. The water is lifted through pumping at a height of 150 meters. This irrigates 5,400 hectares of land in the Purandar Taluka. This project offers an automated, pressurized, equitable distribution network, which is ready for micro-irrigation for an area up to 3 hectares. The unique feature of this project is that it makes the water available 24/7 for irrigation throughout the year to the farmer. We have thus improved the water efficiency up to 35% by changing from the conventional way of open canal irrigation to pipe distribution network. This transformation has also recorded a massive cost reduction of 30%. Additionally, a known social and economic challenge of land acquisition can be overcome by using this system as against using the conventional way. Considering an adequate supply of water, the quality and quantity of crops can be drastically improved. This, in turn, can enhance the social upliftment of the farmers in this project area. This will also have a positive impact on Pune's market. This project comprises of various advanced technologies like equitable distribution of water and pressure through outlet management system, central control and monitoring by SCADA, and the distribution management system. Water meters at 24 hectares chuck. Primary and secondary autofilters have been installed which are necessary for drip irrigation. Residual pressure at 24 hectares chuck ready for drip irrigation. Remotely controlled up to 3 hectares sub-chuck with a centrally located unit. Wireless energyless communication system by radio or GPRS. Vandalism alerts. SMS alerts to farmers. Officials can access the system through internet on their computers or smartphones. Reports and data log available on computer. Smart devices like outlet management system, distribution management system, project.
So this is the last part. So this was the example of Gunzoni irrigation project, which is being executed by at Pune, and this is a 100% pipe distribution network. And I think I have only 5 minutes, so in a very brief, I will complete my presentation. And this is the last part in which I will discuss the challenges and way ahead. So basically, while doing water management, we have external challenges and internal challenges. So external challenges include water scarcity, temporal and spatial variation in rainfall, as we discussed in brief. Then we have uneven spatial availability of water. So 55% is water is available in one basin and 45% is the rest of the basin. Then we have decreasing per capita water availability. Then changing land use pattern. So more and more land is coming under urbanization. That is a concern for irrigation management. Small land holding is an issue. Diversion of irrigation water for non-agriculture use, for example, domestic use, and impact of the climate change. From internal department side, there is an aging infrastructure, equitable water distribution, and having robust infrastructure for that is a big challenge. Completion of ongoing projects is the issue. Then empowering the participatory irrigation management is a challenge. We discussed the water quality. It is a very important issue. Improving the productivity of water, and ultimate last is the capacity building of all the stakeholders, the challenge. And there are several upcoming areas in this domain. For example, riverfront development projects, water transportation, river linking, upgradation and modernization of old irrigation infrastructure. Then disaster management, including drought management as well as flood management. Then there is a draft National Water Framework Bill 2016 and draft Dam Safety Act 2019. And this is last slide. There are some good upcoming areas like drones. So drones can monitor the execution. They can inspect the dams. They can help in carry out the contour survey. They can prepare a 3D model. These drones are very successfully used for the underwater surveillance, and they are used for the obtaining the aerial views. Then canal automation is an important area, and there are some successful example as well as unsuccessful example in a state and country. And this is a slide describing the decision support system and data acquisition system for flood management. So in this system, we install automatic weather station in the watershed area, and we collect the data of rainfall, humidity, temperature, and based on this data, we prepare a model and we simulate that model, and we forecast the probable maximum flood in the rivers. And based on this, we carry out the flood management. Then there is a SCADA for pipe irrigation network, which monitor the release schedule of the walls of the canal system. Then there is ICT. So we can use satellite image, drone, sensor for data collection. We can also use the artificial intelligence for data analysis. There is IoT SCADA for real-time monitoring and control, and this data can be managed very successfully through GIS. And this is the last slide. So VID is the water use shall be made more efficient. The irrigation water use can be made efficient by adopting the micro irrigation and PDN. For domestic recycle and reuse of water is necessary. There are some supply side interventions such as more storages, less evaporation practices, river linking project, and there is a need of demand side interventions such as low water requiring crop varieties and decreasing water demand by efficient water use. And that's all from my side. Thank you so much for patient hearing. Thank you. So if there are any questions, please let me know.
Yeah, I think Bakshish, you can go ahead with yours. Then we can see if there's anything in chat.
Sure. Thanks, Shreyash. So thank you for such an enlightening lecture. I had another question out of curiosity. Recently, central government had launched a scheme on Atal Bhujal Yojana, which is basically for groundwater. And it's not a national, I mean, it's a national level scheme, but for selected states, including Maharashtra. So, so I wanted to understand, sir, since it's a World Bank program where government is pitching in money along with World Bank as form of a loan. So if you could help me understand in such programs which are being initiated by the central government and also involves working and coordinating with the state government. So how are such programs formulated in terms of the consultation which they have with the state government? Because in such programs, it's a central government program which will be done in coordination with the state government. So what sort of consultations happen, and when on the ground implementation happens, if you could help me understand that out of curiosity.
Okay. So I cannot give justice to the Atal scheme because I am not related with that scheme, but I can share the experience of other scheme. So basically, what they did, they appoint some nodal agency like World Bank. So what agency like World Bank do? They come to the ground, they study the situation, and they prepare as is report. So what is the current situation? They assess it and they document it and submit to the state government and central government. In the second stage, there is a consultation in the as is report. The last chapter is generally challenges and lacunas. So after identification of these challenges and bottlenecks, this is a consultative process. So generally meeting is organized at the central level, and they invite all the experts and they formulate a strategy to combat these issues. And they prepared a to be report. So what is a to be state? So they formulate another document, and generally this document is circulated to all the stakeholders, and they take their concerns, they discuss with them and ask them if there are any issues on you want to modify, do you want to modify this document. And after getting their consensus, the report is finalized, and in this report they propose some structural intervention or some intangible intervention as well, like formulation of any act or so. So once this to be report is prepared and submitted after proper consultation, finally government at both central and state government have a MOU with the World Bank, the other agency, and generally in this way this execution happens. There is another way. There are some central schemes. For central schemes, the criteria is already decided. It is a pre-decided. And if state government want to fulfill that criteria, that condition, then they can adopt that scheme. So this is also one of the way in which state can have a central government funding or their knowledge. So is that okay for you? Or I want to ask supplementary.
Yes. Thank you, sir. That gives me clarity on the question.
Thank you.
Yeah, okay. So there is one last question from Digvijay about what is the pipe material used for pipe distribution. systems?
Yeah, pipe. So pipe material, it depends on the life cycle cost analysis. Generally, we carry out the life cycle cost analysis, considering the life of the scheme and cost of capital cost as well as maintenance cost. So generally, if diameter is more and discharge is more, then we use the MS pipe. Then we use the DI pipe, ductile iron pipe, then SDP pipe, PVC pipe, and there are other types of pipe. But generally in Maharashtra, these four types are commonly adopted. And we have UPVC, GPVC pipes, but these are rarely adopted. These MS pipe, DI pipes, SDP pipes, and PVC pipes. These are commonly used type of pipe. RCC pipe is also there, which is also commonly used. And just to supplement that answer, there is a code of practice prepared by the central government, which is also available on the central government website. You can just download and look at the philosophy of design as well as this specification of all and each and every pipe is mentioned in the document. Yes, thank you.
Yeah, so that was the last question. So I think we have had a great presentation and it was a very immersive one, especially from the vast experience that comes with your ground level understanding. And I think if you have questions further also, you can be in touch with Praveen later. And in the interest of time, I think we should close the class now. So yeah, regarding the PPT, we'll share the PPT as Praveen said.
Yes, and this is my email ID. You just drop me an email.
Yeah, okay. Thank you so much. Thank you so much, Mr. Praveen, for taking time out of your busy schedule. And I hope students have learned the best out of this lecture and this helps them further in their career.
Yes, thank you. Thank you and all
Thank
the
you.
best.
Thank you, sir, for the enlightening lecture. And in case if any of us wants to contact you, can he share your email address if that's comfortable with you?
Yeah. In the chat, yeah, it is in the chat.
Sure. I got it.
And I will also share my mobile number in the chat.
I will also share on WhatsApp group.
Yeah, that will be great.
Okay.
Thank you, sir.
Thank you so much, sir.
Thank you and all the best. Bye.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you. Yeah.